All right, you guys, this whole new chapter is about radicals. And let me actually go back to the first problem. Here we go. No, that's not it either. That's not it either. I didn't realize I went all the way back. Okay, so the very first thing you're going to be doing is graphing um, square root functions. So again, like you know that a line, okay, let me make sure I have everything here. Okay, you know that a line goes straight, right? So we know lines go like this, okay? And their formula looks like y equals mx plus b, okay? And then you know quadratics go like this, and that is y is equal to some kind of x squared, okay? And we know cubics go like this. We know shapes happen. This is an absolute value of x, okay? So we know these shapes happen. Well, the square root function is very similar. So exponential goes like this, and log goes like this, right? Well, square root function is very similar to this, but all you need to know is to plug in numbers. That's literally how you can graph any single one of these functions if you want. If all you want to do is plug in values of x, it will always work if you can plug them in correctly. So let's plug in a -7. It says 2 root -7. Well, that's imaginary. You can't have that. Okay, so not a real number is the answer for anything that's inside negative. Remember, you cannot graph an imaginary number in this graph. This is a graph. A coordinate plane is a coordinate plane of real numbers. Okay, imaginaries are floating up there. We don't graph them here. Okay, so this is not a real number. This is going to be not a real number. Not real, not real. Then you get 0. So 2 root 0, that's 0. 0 times 0, 0 times 2 rather is 0. So we have 0, 0, and then 4, square root of 4 is 2. So you're going to go plug that in, square root of 4, cross it off when you find it, you guys, so you don't screw up. 2 times 2 is 4. And that's how you fill in that one. I didn't really put 2 of these because I figured you guys would know how to do those, okay? The next task is to find, to plug in numbers, okay? Here's your function. It's a cubed root. So a cubed root means something to the 1/3. You can put it, that's how you can put it in the calculator, or you can find the calculator where it has this little button like this, and you can plug in the cubed for y right there. Okay, so what we're going to do, although I believe that a lot of these are going to be easy to solve, but I'm not sure. They should be. Okay, so it says find f of -344. Okay, so you can see oh, this is really important, you guys. A cubed root of a negative number does exist. A square root of a negative number doesn't, but a cubed root does, because look, the cube root of -27 is -3, because a negative times a negative times a negative is a negative. Okay, so when you have an odd root pulling out, you can have a negative number. If you have an even root being pulled, that is not real. Not real. Okay, it's imaginary. All right, so we're going to plug in this. Okay, so we're going to go cubed root of -344 plus 1. And you get the cubed root of -343. Now, if you know that, if you have experience, then you probably know that it's 7. I'm pretty sure it's 7. 7 times 7 times 7. Let's see. 7 times 7 is 49. 63, 6, 28. Oh my God, I can't believe my brain remembered that. All right, so the answer here is -7. But you guys can go in and go into Desmos, scientific again, Desmos. Okay, and then you are going to go in and you can see right here, it has that function. So you can put the cubed root on the outside and you could put -343 and look what happens. It gives you the answer right. So you can plug it in there if you want to. Okay, coming back to this. All right, let's go ahead and plug in the next one. Go away. Okay, let's go ahead and plug in the next one. And actually, I'm going to shrink it down a little bit. No, I don't want to shrink it, not enlarge it. Shrink, 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 shrink-a-dink. All right, here we go. So now we're going to plug in 124. So f of 124, all you have to do is it's the cubed root of 124 plus 1, which is the cubed root of 125. And hopefully you know that that is 5, because 5 times 5 is 25 times 5 is 125. All right, next one, onward. Okay, it says find the domain. Okay, so here's the idea of domain. Domain is what x can be. Don't forget what that means, okay? It's basically what x can be, okay? So if your domain defines what you can plug in for x. So the thing with the square root is it can't be negative. Whatever value ends up underneath here, it can't be negative. So the way you find the domain, to find domain, you set that, set that equal to 0. And it's going to be anything that's greater than or equal to 0. In other words, it has to be positive. It has to be 0 or greater, okay? To evaluate a root, a square root, not just a root, but a square root, right? To evaluate a square root, there has to be a number greater than or equal to 0. Because we can find the square root of 0. We just cannot find the square root of a negative number. So what you do here is this plus 2 is not part of the domain. Okay, because it's not underneath that radical and it's not stuck to x. Do you see that? This is going to move our graph up or down, but it's not going to affect our x. So we're going to see how you, okay, so see, I just want to show you this. So really all we're worried about is what's underneath the radical. We take that and we set it equal, greater than or equal to 0. Whoa, sorry. Come on. Is greater than or equal to 0. And actually that's it. It's done. It says write it as an inequality and there you are. Okay, let's try the next one. So hopefully it'll get clearer. Okay, so you take whatever's underneath the radical. In this case, it's 3 plus x. 3 plus x, that quantity has to be greater than or equal to 0 for you to be able to find the square root. Now just solve. X is greater than or equal to negative 3. That's it. You can even check it by plugging it in. You guys look. 3 plus negative 3 is 0. And that's your lower limit. Okay? And that's 0. Do you get the idea? Is that any number greater than negative 3 is going to work. Any number less than negative 3 isn't. Because watch, let's plug in a negative 4. See, you get a negative 1, and that doesn't work. All right, and that's how you can check your answer, by the way. Just pick a number on either side of this mark, per se, okay, of this domain, and check your domain. Let's try again, okay? The domain thing is probably going to be one of the, just something that people don't like looking up, but it's not that hard. Just take whatever's underneath the radical, make it greater than or equal to 0. It must be greater than or equal to 0. Now here's a tricky one. Do you see why? There's a negative here. So here's where you have to remember that when you divide by a negative number, we switch the inequality. And always check your answers, okay? You're like, oh my God, did I do that right? It says x is less than or equal to 4. Well, let's pick a number less than 4. How about 0? Let's check it. I'm going to pick x is equal to 0. It's a number less than 4. I'm checking my domain. Get it? I found this and now I'm checking it. So look, the square root of 24 minus 6 times 0. Is that positive? Check. It sure is. Okay, but let's pick, well, that's less than. Never mind, it worked. It's a number less than, so it worked. We're good to go. Next. Okay, sorry, it's so small, you guys. It says plot 4 points on the graph of the function. Okay, the leftmost point and the 3 additional points. Then click graph of function. So basically, you're just graphing the square root. Okay, so the leftmost point is going to be the lowest number, which is going to be 0. Okay, so if you're just picking your x and your y values, ooh, let's not do y. Let's do f of x because they gave us f of x. Okay, we're going to plug in 0 because it says, this is what we're graphing in case you can't read it. Sorry about it being so small. That's what we're graphing. See how simple that is? It's just the square root of x. Okay, so the square root of 0 is 0. So f of 0 is going to be the square root of 0 plus 5. Cancels, and you just get 5. Let's try 1. F of 1 is equal to the square root of 1 plus 5, which is 1 plus 5, 6. Okay, it wants how many? 4 points. F of 2. Keep going. Square root of 2 plus 5. Let's see. I'm wondering if it'll let you put in the approximation for this because, of course, this is irrational. So it's something like 1.41, but the question is whether or not it'll let you do that. Like, will it let you put 2 and 1.6 point, because this is 1.41. Okay, 6.41. I don't know if it'll let you do that or if you need to pick something like 4 that has a square root, right? And 9, because they have a square root. So if you do f of 4, you get the square root of 4 plus 5. See, the reason why we pick this is it has a nice square root, and you get 7. And then if you pick f of 9, that has a nice square root too. And you get 3 plus 5, which is 8. So probably don't use this one just because of the approximation thing. Go ahead and pick perfect squares for these, okay? Because they end up simplifying, okay? Take a look at that. Pause it if you need to. Next. Okay, plot 4 points on the graph, the leftmost point and 3 additional. Okay, so here's the function we are graphing. F of x equals the square root of x plus 1 plus 3. All right, so what is the leftmost point going to be? It's going to be whatever makes this equal to 0. Remember? Because that's going to help you figure out the domain. The answer is -1. So the leftmost point here, so sorry about this being crooked, is going to be -1. Because when you plug it in, you're going to get the square root of -1 plus 1 plus 3. That's going to be 0, so you're going to get 3. Okay, then we're going to plug in 0 to make it 1, right? So look, if I plug in a 0, it's going to, why am I doing these so long? Holy crap. Let's try that again. Okay, if I plug in a 0, I'm going to get 1. That's 1. The square root of 1 is 1. 1 plus 1, 3 is 4. Okay, let's try the next perfect square, which is going to be, we need to get to a 4, right? Okay, so our perfect squares are 1, 4, 1, 4, 9. 1, 4, 9, 16 would be the next one. But let's try to get to these. So we're trying to get to 4. Okay, so 3 would be the one to plug in. F of 3, because you would get 3 plus 1 plus 3. 3 plus 1 is 4. Okay, the square root of 4 is 2. 2 plus 3 is 5. Okay, and then let's try to get to 9. Okay, to get to 9, we're going to plug in an 8, because the square root of 8 plus 1 is the square root of 9, which is 3, which is 6. So these are the numbers you're going to plug in. Okay, next. Oh, by the way, you'll see what it ends up being. I'm going to go ahead and erase it, but, oh, come on, honey. Okay. It looks a lot like a log. It really does. And it makes kind of, well, I don't know if it makes sense to you. It does look like it. Here's what it looks like. Okay, you go -1, 3, 0, 4, 3, 5, 8, 6. Okay, so it goes like this. Keeps going. Okay, the difference is it has a stopping point. Okay, because we can't go this way because then we enter into the imaginary zone and you can't do it. Not real. Okay, next. Let's try the next one. Oh, wait, hang on. Nope, hang on, let's see. Do the next one. Okay, if we're trying to graph this, let me pause this.
I don't.
All right, here we go. Ready?